Hello students, this video is going to go over percent composition. Now this was a topic that we did go over in pre-AP chemistry, so we're just going to kind of rehash this really quick. So percent composition is telling us how much of a compound or a molecule is this particular element versus how much of it is this particular element. When we determine the percent composition, we can talk about the purity of the sample that we're actually analyzing. When we talk about percent composition, there's a lot of different topics that we can use it for. We can use it for solving for empirical and molecular formulas. We can use it in combustion analysis, which we'll talk about at the end of this unit. So we try to find the percent composition of a substance. You're always going to take the mass of the element, the total mass of the element. So multiplying that molar mass by any subscript from the formula, you're going to divide it by the total molar mass of the compound, times it by 100 to get it into decimal form. So when we look at, sorry, I went the wrong direction. Our chemical compound that we were analyzing in the last video, cisplatin, we're going to find the percent composition of all of the elements in that. So to find the percent composition of the platinum, we're going to take the molar mass of the platinum up here, divided by the total molar mass of the substance, times it by 100. Now we typically round all of our percentages to the hundredths place. So you'll see that's why it's 65.01% PT platinum. Then we're going to take our nitrogen. We have to multiply nitrogen's molar mass by 2. That's why we have 28.02 up here on the top, divided by our total molar mass times 100. So we have 9.34% nitrogen. Same with the hydrogen. We're going to multiply our two subscripts together. So our total mass of hydrogen, which is 6.06 up here. I always round hydrogen's mass to 1.01 from the periodic table. It would be slightly different if you use the 1.008, but you are perfectly welcome to use that number. Divided by the total molar mass here times 100, so we have 2.02%. And then we take the mass of two chlorines up here on the top, 70.90, divided by the total molar mass times 100, 23.63%. You can always add up your percentages after you're done to see if they equal up to 100, or they should be very close to 100 within like a hundredth or 200ths or so, just because of rounding. Now, when we do our percent composition calculations, we're going to also ask you some follow-up questions, for example, about the purity of the sample. So if we have this kind of question, the percent mass of magnesium in magnesium sulfide is found to be too high. What does that indicate about the sample? Is it pure? No. If it was pure, whatever mass composition, percent composition of magnesium you calculated would be the percent that you actually found experimentally as well. But in this case, we have too much magnesium. So we have an impure sample. We have too much magnesium in our sample. Is it possible that the impurity contains only sulfur? What do you think? No, if the impurity contained only sulfur, we would have a higher percentage of sulfur versus a higher percent of magnesium. So we have too much magnesium in our sample, so we have more magnesium present, so perhaps another magnesium compound than just the magnesium sulfide. And that's basically all you're going to have to do with your percent compositions. So if you have any questions, feel free to reach out and let me know.